Okay. Next component. Some books and whatnot leave this out, but I think we should talk about it just because it's, you know, it's there in concrete, and it might actually be placed in concrete, and that's air. Air, you know, seems like, you know, it's you know, obvious, but maybe it's not that obvious when you talk about concrete. I mean, we mix concrete just like we're mixing, you know, a cake batter. You know, we take our cake mix, we add water, some other ingredients, we mix it up. Hey, lo and behold, there's air in that cake batter. Well, we take concrete, you know, cement, water, aggregate, we mix it up. Lo and behold, there's going to be air in that concrete. That type of air that's in concrete is what's referred to as entrapped air. Basically, that's the natural air. That's the air that's just going to be there because, well, what the heck? We had you know, we had air in our atmosphere. We mixed the concrete up, and now we got air that's in the concrete. That entrapped air, probably by volume, would be relatively small. It would be probably between 1 and 3%, depending upon the aggregate size. 3% would be a lot. I think for most mixes, you'd probably down 2% or in that neighborhood. But 1 to 3% we'll say. Nonetheless, 1 to 3%, realize what that means. You know, if you had, you know, a 3 foot by 3 foot by 3 foot block of concrete, and you're talking 1 to 3% of it, if you could force all this air into one place, I mean, you'd have, you know, sizable little chunk of air. All right. Now you can't force it all into one place, but that's what, you know, that's what we mean. So I mean, 1, 2, 3%. It's still, you know, I mean, that's, you know, depending upon what you got. I mean, that might be approaching, you know, a half a cubic foot or so of volume. So, you know, half a cubic foot, you know, that could be, you know, relatively substantial. But anyway, entrapped air. We also have the ability to put air, extra air if you want, into a concrete mix. We have chemicals, admixtures, where we can actually put air into concrete. That type of air, if we're going to use a chemical admixture to put air in, that air is called entrained air. Okay? Entrained air probably would be maybe added to possibly give, you know, maybe 4 to 6% more air. So maybe your total maximum air, you probably want to limit to about 8%, maybe 9%. Okay? Entrained air, though, is on purpose. We put it on there on purpose. So you can imagine now if we got 6, 7, 8% air in our concrete, now the amount of concrete volume-wise is much larger. Question is, why would we want to put air in concrete? Huh?
Dry it out faster, maybe.
Can.
Dry it out faster, maybe.
No, not drying it out faster. Huh? It would be lighter, but it's not that. That's not. Still, this is in small amount. There is a concrete that's known as aerated concrete, where we actually blow air into it, and that air content might be 40 or 50%, and then you are really talking about just a really, really light type of concrete, but it's almost not structural too. So, but why would we? I mean, what's the main reason? Huh? No, not a filler. Well, you know, they do make this pervious concrete now, which has a lot of void spaces, unconnected void space in it, which allows water to drain freely through it, but it's not. It would make the concrete more porous, but that's not, again, what we're shooting for here.
Would you be able to pour it in like cold, more extreme weather conditions, or maybe to make it harder?
No. The reason we do it is to increase durability. And what we're talking about is durability relative to freeze thaw. Okay? Concrete has a lot of water in it. You know, we said 1 cubic yard had, roughly maybe on the order of 250 pounds of water in it. That's a lot more water than is needed to really hydrate all the cement particles. So there's a lot more water in it than it need be. And even after the concrete gets hard, okay, it's there's still water in there. Okay? If that concrete's subjected to freezing weather, what's going to happen to water molecules? They're going to freeze. Water gets bigger when it freezes. Water gets bigger when it freezes and turns to ice. What's it going to do to a hardened mass of concrete? It's going to crack it. And that cracking, I mean, maybe the first crack, a little micro crack, is not a big deal, but that takes place 100 times a winter. And all of a sudden now you're 10 winters into the concrete life. All of a sudden now that concrete's really starting to deteriorate. Okay? And you've seen this around your house or your wherever you live. You probably, if you live someplace for 5-10 years, you might have said, hey, I noticed a crack there in my driveway. 10 years later, what does that crack look like? It's a lot bigger. It's bigger just because water got down in it and froze and chipped a little bit more off, and got down in it and froze and chipped a little bit more off. And you keep on doing that back and forth over time. Hey, you're going to deteriorate, cause a lot of deterioration. Adding more air into it gives the concrete, the hardened concrete, extra little chambers that if water's going to freeze, maybe it's not just pushing on hardened concrete. Imagine, if you will, here I'm this molecule of water, I'm going to freeze, I'm going to get 11% bigger, but now over here and over here and over here, I've got a little extra space to expand into. All right? That's what the extra air is supposed to do. It's supposed to act almost like a shock absorber. It's supposed to, give just extra room for a molecule to expand a little bit, maybe not cause cracking. And it works out pretty well. I mean, they've had pretty good success with this. It does other stuff. I mean, you said, hey, it makes it lighter. Yeah, adding more air, air doesn't weigh a whole lot, So if we have concrete and it has more air in it, I guess it does weigh less. But we don't really do it too much for that. It does actually make the concrete more workable when you do this. I mean, it makes it more fluid, but we don't do it for that. I mean, if we're going to use air entrainment, we're going to key in on durability. What type of concrete would you be interested in using this on? Well, concrete that's used outdoors, okay? Concrete that's subjected to freeze. I mean, if we're inside a building, there's no real reason to have air entrained concrete. I mean, we're not subjected to freezing weather, okay? But, for roadways, civil projects, highways, foundations even, I mean, anything, this is beneficial in all types of exterior type concrete. So anyway, that's air. Again, there's a trade-off there, though. I mean, although we said lighter, what's a negative of more air? Huh? It makes it weaker. I mean, air doesn't really support weight. You got more air in the concrete, you got less paste. You know what I mean? I mean, it makes it weaker. So there is a trade-off there. That's why we limit it to, you know, maybe around 8% maximum air, because, you know, we lose a little bit of strength, but we're able to live with it. Anything more than that, it really starts going downhill pretty quickly. All right? Question?
You said it's a chemical reaction. That's more the powder that they're mixing in with the cement, right?
What? I don't.
You said it's a chemical reaction for the entrained stuff.
It's a chemical additive.
It's a chemical additive, but is it a powder or?
It can be a powder, it can be a liquid.
So then does that take away from the percentage of the other stuff that goes into it?
Generally, it's in such a small amount, it's not going to make much of a difference that way. I mean, we'll talk about admixtures here in a minute, but we have all different